Hey, welcome back. So we're on Mathia and we're getting started on special right triangles. So we finally completed Module 3, Topic 1. Okay, but before we're getting ready for Topic 2, we got to do a little review on what's called a special right triangle. Okay, so let's click and see what we got. Alright, if you look in the back corner of the room, Mr. Miller has hung up posters that demonstrate this look. Okay? The 45, 45, 90. Now what's cool about the 45, 45, 90 is the fact that if we take a square and cut it in half, we have a 45, 45, 90. So now, think of Pythagoras. In Pythagoras, a square, x, 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 x. If we do the simple math of x squared plus x squared equals the hypotenuse squared, that's where we come up with x radical 2. And Mr. Miller is going to talk to you about that in class today. Okay? All right. So now let's think. The hypotenuse is the radical 2 times the length of the leg. Whoa. So now, if we multiply going this way, what's the opposite of multiply? Divide. Divide. So let's actually write that in there. Okay? Multiply and divide. Okay? So, when we go from the leg to the hypotenuse, multiply by radical 2. But if we bring it back out, we divide. By radical 2. So now watch how neat this works. We go from the hypotenuse, we bring it back out. JK, we're going to bring it back out. Take the hypotenuse and divide. Literally, just type that in. So, 8, click on the little radical for square root 2. Toggle outside, we got to have a fraction. We're going to divide out radical 2. So we got a radical 2, enter. Isn't that cool? KD. KD, it's a square. It's got to be the same thing, right? So I'll complicate it just so you see it. 8 radical 2 over radical 2. But it's a square, so we know that it was 8 and 8. Okay, VR. Again, we're going to divide it out. Divide it out. So 12 divided by radical 2. RF, same idea. 12 divide by radical 2. Alright, now, gotta complicate it. Soren is flying a kite on the beach. The string forms a 45 degree with the ground, so we're going to use this little diagram over here. 45 with the ground, and if he lets out, so the hypotenuse, the kite is 16 meters. How high off the ground is it? Well, we have to divide it out. Divide it out. So I'm going to hit the little fraction maker, and we got 16, drop the down arrow, radical 2. Cool. Baked pita chips are often in the shape of a 45, 45, 90. Okay? 45, 45, 90. Caden determines that the longest side of the pita chip. Now, I've done this problem. It's frustrating because they should have used the word hypotenuse. They're calling this the long side of the chip. Okay? So, now, what is the length of the other side? So, if the long side is 3, divide out. Divide out. Okay, so we're going to divide out So 3 radical square root 2. And what is the area of a area of a triangle? Area of a triangle. We know that. Okay. Remember the area of a box, length times width. Area of a triangle. Remember that? 1/2 the base times the height. So now we know that the base times the height, 1/2. Let's try it. Yes. Okay. Now prospect area has side lengths 512 by 512. 512 by 512. Okay, so 512 by 512. A path runs diagonally through the northeast corner, southeast corner, divides into 45, 45, 90. How long is the path? Okay, so if this is 512, radical 2, multiply. So 512 multiply radical 2. Isn't that cool? All right, so special right triangles. And the first couple of problems are all about the 45, 45, 90. So just think of a square cut in half. All right? Okay. So now, 45, 45, 90. This is the same one. I'm going to multiply through. All right. So now, solve using the 45, 45, 90. Use paper and pencil to calculate the answers. Round to the nearest 100th. Gus and Helen went on a hiking trip. They parked the car, and went due south, due east. After hiking 216 feet, started to rain, and they decided to return to the car. Whoosh. The map shows the directions and the distance they hiked before it started to rain. Okay. But then they want to make a straight shot, right? Both Gus agree that the shortest path back to the car has something to do with the length of the hypotenuse. Okay, so remember our hypotenuse. Okay, so the most important thing next week is vocabulary, vocabulary, vocabulary. Two routes are indicated by the dashed lines. Can both routes be equal distance? Now you can just tell by drawing. There's no way that's going to work, so no. What is the approximate distance according to Helen round to the nearest 100th? Helen. Helen believes the shortest route is indicated by the small dashes. So Helen's going to go diagonal, diagonal. So she's got a double diagonal going, right? Okay. So now to the nearest 100. So we got a lot of math here, don't we? Okay. So I'm thinking 72 squared, right, to get this. But we know 45, 45, 90. 45, 45, 90. .45, 45, 90, so 72 radical 2. What's this guy here? 60 and 12. 60 and 12. So we got some math here. So the first one is going to be 72 radical 2. But then we're going to have to add this next piece, which is the distance formula, right? A squared plus B squared equals C squared. So we have the square root of 12 squared plus 72, 60 squared. Okay. What is the approximate according to Gus, round to the nearest? So now Gus is going to take this 130, right? If we put these two together, we have 130, and those two together is 84. So now we have 130 squared plus 84 squared. Oh, 132 squared. Okay, who is correct? Gus. Gus is shorter by 6. No? Oh, 655. I wasn't very accurate, was I? Alright, so we like to make these videos 2 at a time, and then we're going to do the 30, 60, 90 triangle. Okay, so that'll be our next video. See you soon.